and we're going to transfer the data from this graph into a data table that's going to help us do this calculation. Now, you guys should know 6th grade, I'm going very sequentially here. I'm giving you a lot of teaching. Some of you are going to be able to do this like this. Okay, so my pardon to those who have got this right away, but I'm trying to make sure everyone's on the same page here. So when we're calculating our rate of change for our control data, we want to start with what time interval are we going to assess? So for the data that I shared with you guys, the time interval that I'm going to assess is from minute 2 to minute 19. So that's my first step here that I'm going to write in on the left. From 2 minutes to 19 minutes. That's the interval that I want to address. It's the interval that I want to look at. Now in this step here, this is where we're going to write out our slope calculation. This is where we're going to identify what the rise over run is. And so the calculation for that is y2 minus y1 over x2 minus x1. Just as a reminder, the y values, these are our oxygen values, and our x values are time, okay, or minutes. So when we're looking at our x's and our y's, those are what we're looking at, okay? So I'm pulling my data back over. I want to remind you guys that these values right here, these are our x values, and that these values over here, these are our y values. Okay. Minute 2, this is y and x1. Okay. So this is our first initial data set. So this is y1 and x1. And then down here for our 19-minute, this is y2 and x2. Okay. So when we're calculating our rise over run, it's going to be y2 minus y1 over x2 minus x1. So my y2 is right here. It's my y value, and it's going to be 174. 0.0, and I'm going to round that to my nearest hundredth, so it's going to be 0.07. If you want to, yeah, I was going to transfer it over in a second, but you can write it on your sheet now. Okay. Then my y1 is up here, 171.4, and then that's going to round to 2. So those are my y values. This is y2, this is y1. That's this value here. Y2 minus y1. Now x2 minus x1 is a little bit more simple because x2 is a whole number. It's down here, 19. And then x1 is up here. It's 2 minutes. So I'm just going to transfer that into my data table now, which is right here. So y2 was 174.07 minus 171.42 over 19 minus 2. Now what we need to do is we need to calculate this subtraction here and this here. Does anyone have these numbers so I don't have to do it? Yeah, Bjorn? On the top? Yeah. Okay. So 2.67 on the top, and then 17 at the bottom? 6.5. Oh, thank you. Yes. I'm going to zoom in here now. So the top difference, 174.07 minus 171.42 is 2.65, right? Bjorn got that and Emily confirmed it. And then that's going to be over 17. Okay. Now, in order to find the rate, I'm going to divide this so that I get one number. I don't want to use a fraction as I'm describing my rate. So has anyone already plugged in 2.65 divided by 17? 0.155. 0.15. And we would round that up to 0.16? Yeah. Okay. Okay, that's what I got as well. So when I put this into my calculator, I get 0.1555 or 558823. So I'm rounding this to 0.16. And then my units are PPT per minute. So this is my rate of change. So that means that every minute I did my experiment, okay, and we did our experiment for 30 minutes. Every minute that we experimented in this segment right here, we got 0.16 parts per thousand per minute. Okay, so that is the rate that we're going to be using when we compare our data to other sets. You may see data sets that are faster than this. You may see data sets that are slower than this. You may see data sets where this is a negative number, which means the rate went down. That's going to be up to your group to decide. Okay. Now, the last thing, ladies and gentlemen, is being able to take this number and write a sentence about it, which means we want to take this number and describe what that means. So I've created a frame there for you that you guys can use. And what this frame is going to say is, from 2 minutes to 19 minutes, the oxygen concentration inside the biosphere was increasing by 0.16 ppt per minute. Okay, so I'm just rewriting this, but including my times here and my ppp per minute. So from 2 to 19 minutes, the oxygen concentration inside the biosphere was increasing, because it's a positive number, which means increasing by 0.16 ppt per minute. Whoops. Yeah. Those are going to just be part of the notebook check, which we're going to do at the end of class. Did you turn yours in, Avery? That stands for parts per thousand. Yeah, we aren't going to turn that into the notebook. We're just going to have that, excuse me, we're not turning into the box. It's going to be graded as part of your notebook check. Okay, we can check in during the work time today. All right, so here's your goal, ladies and gentlemen. I'm really excited for this next step, because what I want to share with you, ladies and gentlemen, is we're doing this lab unlike any other year that I've done this lab. I've been teaching for a while. So this year we really wanted to make this lab look and feel more like a real data team, where scientists are really going to be reaching out to other scientists to look and see what their results were. Sometimes that's other scientists next door in the lab next to them. Sometimes scientists are collaborating with scientists across the world. But either way, what a big step is when we're looking at data is being able to look at our data, how it compares to other people who do the same thing. Replication of results is a huge indicator of success in an experiment. So if we can replicate or do the same results, come up with the same results over and over again, this strengthens our data. It makes it so that our data is more reliable. It's able to be argued more strongly. So you guys are going to be joining your groups, the ones that you worked with last class, to look at your data sets and find out this calculation. And then what you're going to do is you're going to compare your data set to other data sets for the same variable. So would you guys please flip over to the other side of this practice sheet real quick? I'll bring it back. So flip to the other side where you see a space for yourself to do your calculation of your own data. And then you're going to be calculating the rate of change for 2 other sets. So when you get to your tables, you're going to notice that each table has a poster on it. Okay, this is how Betty and I put these posters together, where each poster is going to have your data set on it, as well as other class periods that did the same variable. So this is the poster that you guys are going to see at your desk. And this is a decrease in temperature, by the way.